Hey Nate, today we're going to be talking about faults, volcanoes, earthquakes, and things like that. Actually, we're going to be talking about a number of different things today, but they all are connected to the activity that's going on beneath our feet and below the Earth's surface. We have mentioned before that the crust of the Earth, the surface of the Earth, is covered with plates that either crash against one another or pull against one another or push against one another. And that causes a lot of energy to be released from the center of the Earth and can very often result in volcanic eruptions or earthquakes or tremors. A fault is basically a big crack in the Earth's surface where the rock layers have either slid past one another or pulled away from one another. And a fault can really occur in one or two, or maybe sometimes a combination of two major ways. One is called the strike slip fault, and the other one is called the dip slip fault. The strike slip fault is when two blocks slide past one another. The San Andreas Fault, that makes up 700 miles of the backbone of the state of California, is a fault that has been formed this way in the strike slip fault. The other way is in the dip slip fault, when one block moves downward in relation to the block that is next to it. And we talked about this last week when we were talking about one of the ways that mountains are formed, not so much by them rising up into through the surface of the earth, but in the movement of one block above another. A volcano is a rupture or a sudden burst on the Earth's crust that allows hot lava, volcanic ash, and gases to escape from a pocket of magma that is located below the surface of the Earth. A volcano is basically a mountain that acts like a funnel from the inner Earth to the surface of the Earth. Volcanoes can lay down new land, and many of the islands in the Pacific, which we'll look at in a minute, like Japan and the Hawaiian Islands, are exactly that, volcanoes that have erupted and laid down new land. The temperature of lava is anywhere from 1,200 to 2,200 degrees Fahrenheit. That is really hot. We would not want to be too near a volcano when it's spewing lava, not unless we want want to get burned really, really, really bad. Most volcanoes are clustered along narrow mountainous belts, and those mountainous belts or chains are located both on land and under the sea's surface. And it's where the fracturing and folding of the rocks occurs and provide channel ways, spaces for the lava to boil up from the center of the earth to the surface. Magma is just a hot fluid or semi-fluid material below or within the Earth's crust from which the lava and other igneous rocks is formed when it cools. And lava is the hot, molten, semi-fluid rock or even solid rock sometimes that erupts from a volcano. We've talked about Mauna Loa in Hawaii. And what did we say about Mauna Loa? We've actually mentioned it in two different classes. What is unique about Mauna Loa in Hawaii? Remember? It is actually the highest mountain on Earth, even though it is not the highest mountain measuring from sea level. Mount Everest gets that distinction, but Mauna Loa basically starts at the bottom of the Pacific Ocean, the seafloor, and is basically much taller, like 3,000 feet taller than even Mount Everest. Um, it makes up it makes up the island of Hawaii, which is actually one of the 8 major Hawaiian islands. Hawaii, even though it's the largest, is not the most populous of the Hawaiian islands, basically because it has five active volcanoes on it. And actually, Oahu, one of the Hawaiian islands, uh, boasts the capital of Hawaii and is the most populous of all the Hawaiian islands. But Hawaii, the island that formed by Mauna Loa, is actually called the Big Island. Indonesia, which is basically made up of islands, many hundreds of islands, has more volcanoes than any other country in the world. As a matter of fact, more volcanoes than all the other volcanoes on land in the world. The Ring of Fire, and you actually have a diagram there of what the Ring of Fire looks like, is the zone of volcanic activity. It's sort of horseshoe shaped that surrounds the Pacific Ocean. It's where the continents that surround it meet the deep ocean trough. So in between that deep ocean trough that is that same horseshoe shape and the continents that surrounds the Pacific Ocean, which are in a horseshoe shape, is where you will find the most active volcanic activity. It's about 25,000 miles long, that whole horseshoe shape, and it has 450 active or dormant volcanoes. Dormant doesn't mean dead, it just means asleep. It's been a long time since they have erupted, but it doesn't mean that they are inactive. So about 450 active and inactive volcanoes. 80% of the most serious volcanoes occur along this ring of fire. We basically have just touched the top of the volcano when it comes to describing volcanoes. But we're going to move down and talk about earthquakes. Earthquakes are usually caused when the rock underground suddenly breaks along a fault. And that sudden release of energy causes seismic waves that make the ground shake. During an earthquake and afterward, the plates or the blocks of rock are moving, and they continue to move until they get stuck again, either stuck underneath something or crash up against something else. And that's when the earthquake finally stops the tremors and the shaking. Earthquakes can change both the surface of the Earth's crust, and they can change the surface of the ocean floor too. An earthquake in Alaska just back in 1974, I think that was the year that your mother was born, raised the surface of a portion of ground 36 feet. That would be a bit taller than my house, 36 feet. Raised the whole portion of ground up that far. Hardly a mountain, but raised it up anyway. Tremors can continue from stored up energy along that fault, even after the rocks spring apart that has caused the original earthquake. I think you probably know that the Richter scale is the measure of the strength of the energy that is released in an earthquake. Seismograph is the instrument that is used to measure that. The Richter scale is basically divided up into 10 elements, not elements, but 10 spaces on the scale, 10 being the most serious earthquake and 1 being the least serious. If an earthquake registers 7 to 7.9 on the Richter scale, that is a very serious earthquake. Um, there are about 20 a year worldwide that register between 7 and 7.9 on the Richter scale. A moderate earthquake usually registers between 5 and 5.9 on the Richter scale, and that can cause a slight damage to buildings and other structures. If there are 20 earthquakes a year that measure 7 to 7.9 on the Richter scale, there are about 500 that register between 5 and 5.9 on the Richter scale every year. But as a matter of fact, there are about 500,000 earthquakes that occur every year. Most of them, by far, most of them are too weak for anyone to even feel. But there's a lot going on underneath the surface of the earth. The country with the most earthquakes is Japan, and the country with the least is Antarctica, way down there at the South Pole. Very few earthquakes happen in Antarctica. But Japan, of all the countries, suffers the most earthquakes. Very often, or sometimes, I guess I should say, there is a secondary result that occurs from earthquakes, and that is tsunamis. When an earthquake quake occurs on the ocean's floor, water moves in to fill in the gap, and long, large waves, like huge ripples, come out from that point. And then when the waves approach the shallow water, the beaches, then they pile up and they grow in height. I know someone who was in I'm trying to think of the country, Nepal, I think. He was there when the great tsunami occurred there. He had come to visit his daughter, who was a missionary there, and he and his wife were out in a boat, and evidently the captain of that boat was aware that a tsunami was coming, and they had been warned, and they took the boat way out into the ocean, as far away from the shore as they could. And they didn't really know what was going on. But his daughter was fine, and they were all fine. But there were thousands of deaths that occurred because the tsunami came on so suddenly, and people were not prepared. So if you are ever in a place and you see these things happening, then head for high land. If you're involved in an earthquake that lasts for more than 20 seconds, then that's a pretty powerful earthquake and may very well result in a tsunami. If that happens, then you get as far inland as you can and as high up in elevation as you can. Climb the highest mountain as far inland as you can get. If you are on the beach and you notice that the water like rushes out like far faster than it would ever normally do in a low tide, then it probably would be a good time for you to head inland and as far as you can and get to higher ground. This message says, evacuate, do not wait. Don't hang around on the beach to see what's going to happen, because once it happens, you are going to be washed out to sea. There is no surviving a tsunami if you are in the wrong place at the wrong time. Those waves come up suddenly and take everything, bring in a lot of junk with them, and take out just about everything they can with them. If you are in a boat, then get out to sea. Don't head inshore, but head out to sea, because the great damage of a tsunami is when it hits shore. A spring occurs when water pressure causes a natural flow of groundwater into the onto the Earth's surface, or moves water through cracks and tunnels within the aquifer. All that means is a spring is kind of a river within an aquifer, a river flowing through water that is either on the surface or just under the surface. So many ponds and lakes are fed by springs, which are just underground rivers that flow into and through the pond or the reservoir or the lake. Those are springs. Hot springs are something even more unique. Hot springs are created when rain and snow seep below the Earth's surface as groundwater, and they hit a solid rock where they collect in pools or aquifers, and magma from the center of the Earth heats that water, which then rises back up to the surface through cracks in the Earth's crust that are called vents. So it's water that collects as an aquifer underground and gets heated from the molten stuff that's deep down into the earth, and then it rises up to the surface. Around where Uncle Mike and Aunt Margie live, there's a town called Hot Springs, and there are places where you can go and go into a big pool that is basically heated from these hot springs that come up from the earth. And actually, Auntie Heather and I went to a Sir Speedy meeting in Arkansas, and I don't remember the name of the town there. It was probably Hot Spring. Oh, it's Warm Springs. Yes, it was Warm Springs, Arkansas. And it was the same thing. You could go into these pools that were heated directly from the hot water that came up from underneath the surface of the earth. Kind of interesting. Geysers are hot springs in which the water intermittently boils, actually comes to a boiling temperature, and it sends a tall column of water and steam into the air. You may have heard of Old Faithful, which is a geyser in Yellowstone National Park in Wyoming. And Old Faithful faithfully erupts every now and then, sending a plume of boiling water up into the air. Again, you probably don't want to get too close to Old Faithful because that water and steam is very hot. Caves and caverns are usually natural voids that are below the surface of the earth. The space underneath the earth would be greater than the opening that actually comes out of the surface of the earth. A cave or a cavern is defined as a place underground where a human being can actually stand up. It can also be formed by the action of moving groundwater that dissolves the rock that it comes in contact with and forms tunnels and irregular passages and even large caverns. And evidently, you don't remember being in the cavern in West Virginia when we were there visiting Uncle Mike and Aunt Margie, but we saw the stalactites and the stalagmites, the mineral deposits that drip down from the ceiling and come up from the floor. There are even caverns. Peepaw and I went into a cavern when we were in Colorado where there was actually a river running through the cavern. And so we took a boat ride through this enormous cavern, which was underneath the surface of the earth. Really rather amazing. So there are a number of different ways that caverns are formed, but they really are just voids, huge voids that are underneath the surface of the earth. Caves can have their entrances on the surface of the earth. Canyons are deep valleys with high steep walls that you go in between, and a box canyon. Again, Peepaw and I have actually been into a box canyon. There is a small town in Colorado called Ouray. It also happens to be the world's capital for hummingbirds. There are hummingbird feeders hanging on every building and every porch and every place you look. And thousands, if not more, hummingbirds flying around, but I digress. I was really talking about box canyons. Ouray is a box canyon. It is surrounded by sheer cliffs on three sides. A box canyon only has one entrance to it on one side of the canyon. Other than that, it is surrounded on the other three sides by steep walls. Glaciers, just to bring together what we've been talking about here, is a large ice mass that slowly moves downhill across the Earth's surface. They are very heavy and they collect all kinds of rocks and soil and sometimes even whole forests as they are moving on their journey southward. Can collect all kinds of things in their path. We've talked about moraines before. Examples? Give me two examples of a moraine. Two? Long Island and Block Island, yes, are moraines. Just junk that was deposited there by a glacier that left left what it collected there. Most of Greenland and Antarctica are covered with a broad sheet of ice that's called a sheet glacier. Um, Glaciers continually freeze and melt and freeze and melt. And an iceberg is just a part of a glacier that has broken off and off the edge of the glacier, and they float in the ocean. Glacier icebergs can be extremely dangerous to boats, to sea travel, because when you see an iceberg, you're only seeing about 10% of it above the water. 90% of it is below the water and is much wider than what it is that you're seeing. I believe there are a few major ships like the Titanic that sunk because they hit an iceberg. Mountain glaciers are located in the high mountains. Our last lesson, I think I showed you one of the mountains in the Tetons in Wyoming that still had a glacier attached to its slope. But those mountain glaciers that are located in the high mountains form valleys and deposit soil and rock as they move along. Next lesson, we're going to be talking about weather and how weather affects the surface of the Earth. But that's enough for today. And we will look at some of the diagrams that I brought for us to look at.